I basically got my paradigm shifted and realized that the way science should be done is that you're shifting your paradigms all the time, that you should have a large variety of ways of looking at things. And what science attempts to do is find right answers. And that's not really the way the world works. If you understand something one particular way, and actually there's a bunch of different aspects to that thing, then you don't understand it at all. And there's a good Einstein quote about that if you don't understand something several different ways, if you don't have several different independent ways to explain something, then you don't understand it. So science has one way to explain most of everything, which means that science doesn't understand the world. But this electricity lecture is sort of a microcosm in physics, and the same things that are sort of unsettling and new and different in this, and it's just elementary school science. You can almost pick any topic in science and go into it in depth and find all kinds of things that scientists would be aghast about. And it's all conventional. This isn't really alternative science at all. It's alternative ways of looking at conventional science that give you insights into it and lets anybody have nonverbal visual understanding of it. But yeah, but that means you can exceed a physicist. If a physicist has a math-based understanding, and how engineering and science works is that you learn an alternate language to describe the world, but you can't explain it to anybody else if they don't learn that language, and that's mathematics. So a typical scientist thing is to say to somebody who wants to know something, it's too complex, I can't understand it, you have to go and take several years of advanced math, then we can talk. But that's an excuse, not a reason, because you can explain things with all kinds of analogies, and mathematics hobbles your understanding because you can't explain things to yourself in many cases if all you have is a set of equations and you don't know what those equations are really describing. And the world is usually richer than the math that's used to describe it. So this is the non-math version of how electricity works. Here's a question that's never answered, and a lot of people ask it, and that if you ask it, you'll get answers, but usually you won't be satisfied. And as a title of a talk, this one is more appropriate. And here's why, because the very first thing I did when working on the electricity museum project was after realizing that there was a big problem with the textbooks, I went looking for a way to explain electricity. And we have to know what electricity is if we want to explain it. So I went to all kinds of different reference books and found how the word is defined. Very simple definition. And the earlier scientists used this definition. There are two kinds of electricity, positive electricity and negative. So electric charge is electricity. Very clear, unequivocal definition. An electron is a particle of electricity. Then you go to another dictionary or encyclopedia. And now electricity is the stuff that electric companies sell. But there's a problem with that because in wires, the electrons, it's an AC system, the electrons vibrate back and forth. None are ever gained or lost. They don't go anywhere. So if electrons are particles of electricity, then electric companies don't sell any electrons. Electrical energy is not electrons. An electron isn't a particle of energy, it's a particle of matter. So stuff is made out of electrons and protons and neutrons, etc. So if electricity is electrical energy, then it's not electrons. So now you have these two are in conflict, yet if you look up the word electricity, often you'll see kilowatt hours of electricity. So the stuff that electric companies sell is supposed to be electricity. And you can look for some more references and find that the different kinds of electricity are bioelectricity, piezoelectricity, hydroelectricity, that these are all separate kinds of electrical phenomena that involve electrical things. So if electricity is a kind of a phenomena, then if you comb your hair and it stands on end, that is electricity. It's an electrical phenomena. Or if you find electrical effects in nervous systems, or you get shocked from electric eels in the Amazon, that's bioelectricity. It's a different kind of electricity because that electricity is a class of phenomena, and you can have all separate classes. Lightning is atmospheric electricity. It's sort of like a subject area, a title of a book, that you could have books that are exploring bioelectricity or triboelectricity, but these are not stuff and they're not energy. It's more like geology. Geology isn't a substance, but bioelectricity, triboelectricity also aren't some substances. And then here's what the elementary school textbooks have to say. The two kinds of electricity, and this is what everybody is forced to learn, is static electricity and current electricity. And static electricity is the useless one that's only in clothes dryers, and current electricity is what electric companies sell. And then they'll also say that electricity is energy. But they'll also say that piezoelectricity is a kind of electricity, and bioelectricity. And of course, there's only two kinds of electricity, negative and positive, and the electrons are the particles of electricity. So what's electricity? There it is. It's easy to understand.